Black holes are strange objects we stumble upon in space. They may be not simplest mysterious and really fascinating to astronomers, but also noticeably a powerful force. A black hole is a place in area wherein gravity pulls a lot that even light can't get out. The gravity is so sturdy due to the fact matter has been squeezed right into a tiny space. This could occur whilst a star is dying. Because no light can get out, people can't see black holes. They're invisible. The purpose why we can realize black holes' existence is due to the fact space telescopes with special gear can help discover black holes. The unique tools can see how stars which might be very near black holes act in another way than different stars. So what is the connection between the South Atlantic anomaly and black holes? The South Atlantic anomaly, SAA, refers back to the region in which the Earth's internal Van Allen radiation belt comes closest to the Earth's surface. This results in an accelerated flux of active particles in this location and exposes orbiting satellites to better than standard degrees of radiation. The effect is as a result of the non-concentricity of the Earth and its magnetic dipole, and the SAA is the close-to-Earth place wherein the Earth's magnetic discipline is weakest. The shape of the SAA modifications over the years. The South Atlantic anomaly is of exquisite significance to astronomical satellites and different spacecraft that orbit the Earth at several hundred kilometers altitude. These orbits take satellites through the anomaly periodically, exposing them to several M0 INUTs of robust radiation, because of the trapped protons inside the inner Van Allen belt, whenever. As described in ERA Overview's article, the vortices which can shape in turbulent water are an acquainted sight. Edgar Allan Poe described simply the sort of whirlpool in his short tale A Descent Right into a Maelstrom, which he posted in 1841. The brink of the world turned into represented via a large belt of sparkling spray. However, no particle of this slipped into the mouth of the awesome funnel. On this passage, Poe describes one of the important function of those rotating bodies of fluid, that they may be idea of as coherent islands in an incoherent drift. As such, they're essentially unbiased of their surroundings, surrounded by a apparently impenetrable boundary and with little, if any, of the fluid inner them leaking out. In case you are wondering that this description has a passing resemblance to a black hollow, you'd be right. Haller and Baron-Vera positioned this similarity on a proper footing by way of describing the behavior of vortices in turbulent fluids using the identical mathematics that describe black holes. On this photo, Poe's extensive belt of gleaming spray is exactly analogous to a photon sphere round a black hollow. That is a floor of light which encircles a black hollow without getting into it. Haller and Baron-Vera cross on to show that each vortex boundary in a turbulent fluid includes a singularity, much like an astrophysical black hole. That has crucial implications for the look at of fluids and the identification of vortices, which might be otherwise problematic to outline and notice. In this case, it is simply question of looking for the singularity and the boundary that surrounds it. And that's exactly what Haller and Baron-Vera have done in the pattern of currents in the Southwest Indian Ocean and the South Atlantic. A well-known phenomenon in this part of the world is called the Agulhas leakage, which comes from the Agulhas current in the Indian Ocean. At the end of its southward flow, this boundary current turns back on itself, creating a loop that occasionally pinches off and releases eddies, Agulhas rings, into the South Atlantic, they say. These guys used satellite images of the South Atlantic Ocean from between November 2006 and February 2007 to look for vortices using a set of simple computational steps that spots black hole analogs. In this 3-month period, they found 8 candidates, 2 of which turned out to be black hole analogs containing photon spheres. We have found exceptionally coherent material belts in the South Atlantic, filled with analogs of photon spheres around black holes, they conclude. That's an interesting result that could have significant implications for our understanding of the way ocean currents transport material. Since anything that gets into these black holes cannot get out, this should trap any garbage, oil, or indeed water itself, moving it coherently over vast distances. Beyond the mathematical equivalence, there are also observational reasons for viewing coherent eddies as black holes, say Haller and Baron-Vera. The work also raises the possibility that black hole analogs will occur in other situations, such as in hurricanes and not just on Earth. By this way of thinking, the Great Red Spot on Jupiter might well be the most famous black hole in the Solar System. An intriguing possibility is that such remarkable vortices could be gateways to parallel worlds or other dimensions.